Thank you everyone for joining us today. Uh, the topic for our discussion is, as you can see, Edge and Beyond. This is the part B of it, where we are going to talk to some of the doyens of the industry on how 5G and edge computing is changing the data center industry. You know, the convergence of 5G and edge computing is fueling innovation across multiple sectors in India. And some of these we're going to discuss today. Uh, what challenges are presented by this fast pace of innovation, where you require a considerable amount of infrastructure investment and spectrum allocation across board, is something that we need to figure out. Some of these challenges could be, you know, workforce related, investment related, as I mentioned, spectrum related. And also we'll try to address a sort of a digital divide which is coming through if we get time. But this synergy of 5G, edge, and data centers, what it does is it provides you with a lot of enhanced connectivity, which is faster, low latency bandwidth. So with that, let me introduce you the esteemed panelists that we have. It is an absolute privilege for me to be part of this panel, along with some of these leaders of the industry. We have Shri BP Singh with us. He is the Senior Executive Vice President for Cloud Business Platforms and Services for Reliance Jio. Mr. BP Singh has been instrumental in building world-class hybrid and edge cloud management platforms available on SaaS as well as on-prem platforms. He comes with extensive experience in building scalable business platforms, deploying complex solutions, and managing the life of such large clients. Before joining Jio, he was an executive director at IBM. Next to him, we have Mr. Gulshan Khurana. He is the executive vice president for transmission and core planning and technology at V. He is a former Reliance executive and has also led sales and consulting in Asia Pacific and Japan with Oracle. So he comes with 3 decades worth of experience in this industry. Next, we have Peter Weglitsky. I hope I'm pronouncing it right. He is the product marketing manager for AMD. He leads the telco segment in the AMD server business unit, and he's got over 2 decades of experience in semiconductor industry, focusing on networking and telecom solutions. Prior to his role with AMD, he held a number of business development and systems engineering and marketing positions across Motorola, Freescale, NXP, and AMD as well. Then we have Sardar Burrell. Burrell has an expertise in wireless technologies and software development. He is the product manager for telco at Canonical, the company behind Ubuntu Linux systems, which all of us have used growing up. It provides open source, full upstream, secure, cost-efficient, and carrier-grade infrastructure solutions for telcos. He has previously worked in the 5G Innovation Center at the University of Surrey. Then we have Dr. Guru Prasad. He is the head of excellence, IoT edge and connectivity and technology strategy at Bosch. Dr. Guru is presently responsible for technical strategy for Bosch India, driving Center of Excellence in the edge and connectivity space. His technical expertise includes innovation strategy, technology strategy, sensors, instrumentation, digital transformation, and data analytics. Then we have Mr. Pradeep Nair. He is the Vice President and Managing Director for India in VMware. He leads their sales and marketing operations in the region. VMware Telco Cloud Platform combines a suite of products and services to help CSPs modernize and virtualize their network, and ran by deploying power of automation and orchestration with multi-cloud platforms, edge computing, and private MEC 5G. With that, let me start the panel with Mr. Brijpal Singh. Mr. Singh, we were discussing outside about the advent of edge and 5G in data centers. What do you think is the primary driving force behind the need to redefine these 10 data centers?
So there are, hello. Yeah. There are 2 major factors. First is rapid evolution in data center technologies. And the second is growing demand of data center infrastructure, which includes compute, storage, network, and many more business platforms which are required. There are several reasons which contributes to this particular need. The top factor is explosive data growth, which is, as we all know, human and non-human, every single thing consciously or unconsciously is generating data. So even while we sleep, our mobile phone does the talking, or even while we speak, this data is getting streamed. And hence there are tons of business cases which have emerged. That forces that this data actually gets processed as early as possible to generate necessary business insights so that this data can be monetized. In fact, our chairman Sri Mukesh Dhirubhai Ambani identified this few years ago when he said that data is new oil, and that actually phrase is proving to be true. Data as such actually has been there since many years, or even in the ancient times. It's just that availability of data and the processing of data wasn't as easy as it is today. Even if when you look at some of these algorithms or the which we call AI, ML, or regenerative AI, the fundamental models are actually mathematical in nature. So they had been there, look at all the books which are there. They are in 1950s and 1960s. So all these capabilities had existed. It's just that we didn't have the capability to extract this data and process this data and make some sense out of it. So that has happened now, and that is actually forces with quite a few constraints on the data center or the digital infrastructure. The second main factor is advancement in technologies. So today, with the advent of regenerative AI, analytics, big data systems, IoTs, there is a constant demand of different kinds of infrastructure. So the infrastructure which used to foot the bill actually is not enough. Today, all these latest technologies, they need GPUs, they need different kinds of data center capabilities. Erstwhile, there used to be data center which used to have, say, one rack with 5 kilowatt, but today 30 kilowatt per rack actually is the norm. And reason for that is because the business demands is changing. You want to process that much faster. The third is energy efficiency and the sustainability. So with the growing awareness across the world, data center models actually are being changed so that they become green and they become carbon foot efficient, right? So that we actually meet the sustainability standard. In fact, this particular area, when it comes to sustainability, it is not only changing the data center models, but it actually changing the technology architectures, the way business applications and the platforms are being built. So just for example, when you build an application, right, you might build an application which is most optimal, or you might build an application which is not so optimal. So when you build application in the code which are not so optimal, they end up using more compute. What that results into is more energy. And hence, this paradigm of sustainability actually is putting constraints. How do you build data center? How do you build your applications? And how do you kind of, manage them? Because if you don't manage them well, then they are going to be less and less efficient. And hence, these constraints actually are being laid on the data center technologies as well. The next is the scalability. Today, there is a need that data center can scale up and scale down depending on the business needs. So that has led to a different form factor of data centers. So, you must have heard of modular data centers, which can be, plugged in a space of 30 days, and they are kind of, operational. But that puts many other constraints in terms of how do you manage its power, how do you manage, cooling, how is the efficiency, how do you guardrail the physical security of these smaller, sites which can be plugged in anywhere. The next is the edge computing, right? So there is a demand, and this is no different. These models actually are repeating in itself. A few years ago, when big data came into picture, there was a advent of Hadoop, and what did Hadoop do is brought data closer to the compute. So while it's kind of losing its sense today, but that's exactly happening on the edge as well. Compute is moving closer to where the sources of data are, so that the relevance of that data actually becomes more relevant. So with respect to different industries, there is some data which has got its relevance. If you process it in, let's say, next 5 minutes or 6 minutes, it loses its significance if the processing time increases. And hence, edge computing is putting constraints as to how do you build all these capabilities on the edge, which is closer to the, closer to the data sources. Next is security and compliance. Now, with cyber threats coming into play, so there are quite a few regulations in different countries, GDPR, CIPAs, and they are putting constraints in terms of what kind of security guardrails your data center has to have. All right. The next big factor is cloud connectivity. So gone are those days where you could build applications, either they were on-prem or they were public. There is a demand where applications actually have to use best of both the worlds. So a part of the application can run on-prem, part of the application can also run on public, and hence there is a need of hybrid cloud infrastructure, and that puts again certain requirements on how do you build your data center infrastructure. Resilience, redundancy is another key factor, because expectation is that these data centers are resilient with respect to any turbulence in the environment, so that they could deal with it, and they have to be available all the time. So availability is given like electricity and water. Nobody questions those things. They are available to everybody. Digital transformation, which is causing every enterprise to rethink, to redesign their applications. All right, and everybody wish to make use of best of the capabilities across how much you put on-prem, how much you put on edge, how much you put on public cloud, so that the whole, the delivery to the business actually become more and more efficient. So these are, some of the reasons which are really driving the innovation which is happening, and innovation in data center space actually are happening every single second in terms of making them efficient, making them modular, speed to go to the market in terms of plumbing your data centers. So these are some of the key factors driving the architectural changes in the data center space.
Yeah.
Thank you.
Thank you. So you touched some really pertinent points on scalability, sustainability, and the location is a very important part of a data center. So with that, I would like to ask Mr. Gulshan Khurana as well. So basically, when you're talking about edge data center, availability has to be good, your sustainability feature has to be good. So how crucial is the location of that data center per se when it comes to high connectivity and a sort of low latency rates? That's what the current industry is moving towards, right?
The entire crux of discussion happens to be on what should be the ideal location, because
Correct.
we have centralized data centers, everybody has. We all serve our consumers, millions of consumers. So why is this debate happening on where should it be placed? As you rightly said, Mr. Singh, very correctly, the data analysis has to happen closer to a consumer where data has been produced. That's very important. This is where the entire discussion started. Where should we put it? The second biggest important part which plays a role on where should the data center be is the consumption. The data production is happening in leaps and bounds. I mean, we have seen the data handling nodes are going to 400, 500 GPS. Do we actually build smaller nodes, bigger nodes? Where should we put them? Because consumers' consumption is most important. I need to find a balance where I put my data node in. Do I put it in the centralized data center? Do I go close to consumer? It will purely depend on the consumption pattern, consumption requirement of the consumer. Is an application which is very, very high in throughput, requires low latency, of course I need to go close to the consumer. But then there's a cost. So economics has to play a very important role. Where do I go? Do I have 2 locations, 3 locations, 5 locations in every PLMN, which is close to consumer, or in a centralized database? Cost of the transport, which is to be built to handle this data, and service analytics to be done on the data, will play a very, very important role. If the service consumption requires high amount of analytics, is a very, very extremely high throughput, requires low latency, I need to propose close to the consumer. But is the consumer paying for it? Is the revenue enough to build so many? So this was a big battle between when the public cloud came in saying, okay, we can do it as a low cost, we can do it on a pay-as-you-grow model, we can do highly modular structures, but the reach is a difficulty for them.
Correct.
We as telcos, we have a reach. We have more than 120, 130, 140 locations where we can serve. But then does it make economic sense? So I think to summarize the discussion, service consumption, service analysis, number of bytes being consumed, does it make sense to go close to consumer? Or does it make sense to keep it back on a centralized data center, on the cost of transport, on the severity and the need of the consumer would define the locations?
Yeah, I mean, consumer journey, like any other industry, is extremely important data center industry as well. And with that, I would like to ask Peter, this whole customer experience, and how will it change, the end user customer experience? How will it change with edge computing coming to data centers?
Absolutely. So this is a great question. How the benefits that our features of the edge are going to be actually passed as a benefit to the end user and to the consumer. And I think that there are probably 3 areas that I would focus on. The first one I would call richer and fuller experience and services with increased performance and closer to the user with decreased latency. Such activities like online gaming, for instance, AR, VR activities will become much more real and much more, more immersive experience. Also, because there will be tailored services and location-based services that will give extra experience to us as consumers. Tailored services, we experience this already. When we finish a movie in a streaming service, we will get a recommendation immediately about other movies which are based on previous history, on our preferences, and so on. The same thing goes with for instance, news information and services. But because the data center, edge data center serves a certain geographical locations, you can get services that will be very relevant to the consumer. So things like, which are very specific, to the situation that is happening at the time, whether it's a weather, traffic situation, events that are happening in the community, at school, you can get this type of notification and, and get a better, visibility of what is available and what you can do. Also with the location-based services, proximity marketing comes into play as well. For instance, if I pass a store that I shop in and edge compute infrastructure really senses that, they can push the notifications to me about new offers in terms of products, rebates, and coupons and this type of thing. So again, gives us this more information which is very relevant, which we can use to in our decision making. So that's one area. The second area I would call peace of mind. And that comes with the fact that both the security and also the privacy of data. The fact that our personal data will be stored not in some other geography, but fairly close to where we are. It gives additional peace of mind, actually, especially that there will be a lot of sensitive information like health information, which is quite important to us. Another one, which is maybe not as intuitive from the experience, direct experience for the consumers, it will be a data bandwidth. if we communicate with the data centers hundreds and maybe thousands kilometers away, this massive traffic is going back and forth. If this traffic is more localized, then there is service providers get a little bit of relief, and they can really plan the networking usage in a different way to provide the better services. So that's the second area. The third area I would call new services. And there is a number of new services that will be coming, So for instance, the first one in the enterprise, there is more and more private 5G networks that are coming up. We were talking with Guru exactly, sort of a few minutes ago about that. And what is interesting is actually, the fact that, with many of these private networks, especially in manufacturing, you need to have real-time processing, data processing. You need to have data analysis done immediately and decision made quickly. If you've got moving robots, manufacturing cars, for instance, you need to have this real-time capabilities that edge compute really offers. The same thing in warehousing. If you're using robots, or if you're using, for instance, drones, collision avoidance is absolutely key. So you need to have these real-time capabilities. For the consumers, on the other hand, retail will be a very interesting area that will be developing. It will be really leveraging a lot of edge compute as well. You know how, for instance, shopping for clothes, it's typically you browse things and you go to the fitting room and all that. It can all be changed with AR and VR. You will be able to really see yourself in a new piece of clothing and change size, color, different style, sort of immediately. So this is a much, much better experience. It is also very beneficial for the retailer as well. They don't have to carry all of the inventory there. You select a piece of item, and a piece of clothes, a new item. They will order this online, will be delivered to your home. So this is a win-win situation on both sides. And my maybe final example I would give is in education, and again comes from the AR/VR. Can you imagine how enriching education will be with using AR/VR, for instance, in the history lessons, when students could be transformed like 400, 500 years back, and be eyewitnesses, some battles, witness some debates in the parliament, watching, the ordinary life. Of course, there will be a lot of content that will be needed to be created. It's a question if, as soon, rather, when is it going to happen rather than if it's going to happen. So the capabilities that edge computing is providing is definitely going to enrich our experience as consumers.
Yes, thank you. Some of this customer journeys that you talked about does require a movement away from your traditional models as well, and that's where I come to, Viral. At Canonical, you are Viral, you are known for moving outside the traditional models across. So, when it comes to edge data centers and and their potential impact, what are your thoughts around that? How do we move away from the traditional data center model on this?
Thanks very much. Previous speakers also talked about a lot on the effect of edge compute and the need for edge compute. It's essentially about bringing better performance to end users so that they can have better quality of experience of any service they receive. So the idea for edge compute is essentially enabled businesses to also provide their customers with better experience, but at the same time, maximize their profits, so maximize their operations, automate their operations better, because then you have this closer interaction between a business service deployed at the edge and their devices and their users, essentially. So edge compute, in that sense, is a driver behind edge clouds. So basically from the core cloud where you run all the services at a single place in a massive data center or perhaps cluster of data centers, now you basically push all these services to the edge of the cloud, edge of the systems, closer to the users and devices. And in doing so, you can establish your services closer to those end users and basically provide them with better services. So what is the change here? Essentially, the change is to improve service, but at the same time, you need enablers to make this happen. So when you have data centers distributed around the country, closer to end users, you need data centers as well. That's where the edge clouds come from. So to enable that, obviously, you can have racks of servers where you're running your systems and services. But if those systems are actually fixed services, so basically you run and install them once and go away, that will not solve the problem. So you want some sort of flexibility, some dynamism in deployment. That's what businesses are looking for as well. So when you have an application deployed at the edge, you want this deployment dynamically done and then automated as well. So automation is really important in terms of services and services provided. Also automation in terms of life cycle of the events that the services you provide. So you deploy, you automate the deployment, and at the same time you automate the life cycle of your applications. To provide that flexibility, as you know, there is virtualization platforms that come into place, such as OpenStack, Kubernetes, and all types of virtualization systems come to our help because we can now run services and applications in real time as a virtualized service. So you deploy them in real time dynamically, and you also orchestrate their operations. That means you need systems, that dynamic system at the edge of the network that can carry this type of services as containerized cloud-native functions. So that means you need this kind of virtualization systems, but at the same time, these systems need to work in an automated way, in a secure way, in a minimal way. Because the edge cloud is not really essentially the same as the central cloud. Your scale is different. Your number of servers there is different. The availability of your staff to service those sites is also different. So the business model is different. That means the systems must be autonomous. They must be secured, and also they must operate in an autonomous way. To provide that, you also have inbuilt security. So security in terms of your operating system, in terms of also the virtualization system you run on. So you need to secure the site services running there. This is especially important for 5G services because as you know, in 5G communication systems, you have disaggregated services. So basically, your core network is now distributed across the country. You can run your data plane closer to the edge. That's also, again about improving the performance. Because data plane performance is so important in telecommunications that end users want fast service, right? But also business want fast service. Piotr initially talked about private mobile networks. This is so important now because edge computing has such correlation with mobile, private mobile. Enterprises will want that capability. They want that real actionable outcomes on their services and really close interaction with the devices. That means you need really real-time systems, real-time from operating system all the way to systems. So that enablement from silicon all the way to your application must be there so that your interaction with your services and devices will be fast. So if I want to summarize that, edge clouds bring performance to users. They are large in number, they're close in proximity to devices and users, and they will be distributed around the country. And you want automation systems, you want repeatable and automated deployment experience for your applications or also for your services. And they need to have the latest improvements in terms of performance, such as real-time operating system.
Thank you, that was fantastic. Now, of course, there are a lot of risks that you talk about, Viral, and some of these risks and problems, edge data centers, edge compute data centers do, Dr. Prasad, they do occur in an IoT-based ecosystem, right? So what are your thoughts around that?
So good afternoon. I'm Dr. Prasad. I come from Bosch. There are two major roles Bosch is playing in edge and 5G ecosystems, especially in India. One in the sector of non-mobility, where we look at factories for future. We are end users of edge and 5G, where we are expected to completely automate the entire shop floor, where we run millions of parts per minute, and then drive efficiency in such plants where we are end users of this entire edge and 5G. On the other side, where our bread and butter lies is mobility, where we connect cars, where we talk to OEMs to provide this technology. In this space, we work as technology enablers, as tier 1 companies to enable Mahindras, Tatas, Audis, BMWs of the world. So let me put my perspective. I think Mr. Singh and Mr. Peter has very clearly covered the essence of edge compute and 5G. But if I summarize both of them in one sentence, traditional IoT systems today are limited by majorly 4 issues. One is latency. I think what is latency is addressed. Second one is bandwidth of the data or the network. Third one is cloud storage cost. And fourth one is data privacy. If you look at edge compute, I think it does any one of them or all of them. Now let's come to a particular case of mobility. By 2030, most of the analytics says every car on road is expected to generate about 5,000 GB of data per day. Just imagine 5,000 of GB of data every day per car if you want to analyze. And the expectation here is you want to drive car autonomously on roads, which means you're looking at least L4 and L5 ADAS functions. And what is the expectation here? The entire inference, I'll explain you what is inference. The entire inference is expected to come before 20 milliseconds for you to take actions, right? So let's now go to the traditional IoT stack. We have sensors at the bottom layer, which grabs this data. You have acquisition units, which collects this data. You have middleware, like an operating system and middleware, which takes the data from the sensors, and through the network, you push this data to cloud. This is one way. And in the cloud, you have a fleet of AI algorithms. Let's take an example of a camera on the car, right? It gives you 15 to 20 frames per second with high resolution data. Just imagine if you really want to drive your car with CV-based application using traditional IoT, which is cloud-based system, God must save us, right? This is where we are looking at alternative technologies to cloud, which helps us in addressing latency, cloud bandwidth, cloud cost, all of them. So what we are looking at is bringing certain architectural changes in the IoT ecosystem. For example, I think people are also talking about what is edge, right? When you talk to a sensors company, they say my sensor 5 years back was just a dumb sensor, which was giving me an analog output. Now I have bought intelligence into my sensor. I have bought a small capacity of data storage, and now I call this sensor as an edge sensor. When you come to somebody like telematics unit, which actually grabs, or you can say a gateway, right? They say any system will actually have a circumference in which the last entity is gateway, which means the entire system data gets accumulated at the gateway, and the gateway sends the data to cloud. Now, before sending this data to cloud, you run your analytics in real time using all the technologies what we have mentioned to ensure you neither ship the raw data nor wait for the response from the cloud. And then run your analytics on the device itself. So I'll take a last example of a car. So if you look at car, you have engine control units, which is ECUs. Next you have zonal computers, where you have multiple ECUs connected to a zonal computer. Next comes vehicle computer, where for an entire vehicle you have one computer. And then at the end you have a telematics unit, which actually sends the data to respected cloud, which is through GSM, XYZ. Now what is edge in this context of mobility? If you run your AI loads, for example, I have a sensor, which could be camera, connected to an ECU. If I run my AI loads or AI models, taking the data from the sensors in the ECU itself, I'm talking about the first layer, in the ECU itself, that could also be edge. Super mission critical, time critical applications have to adopt AI edge compute at the lowest compute hardware available in the system. So this is one. Second, imagine I have, say, right now we are looking at about 200 to 400 sensors in a car, which is humongous number of data. Now, if you look at this and then say, my ECU does not have compute capability, can I now distribute the load? And this is where a new topic called as distributed edge computing comes in. I have hundreds of ECUs in a car. Rather than using one ECU for one workload, can I distribute the load across multiple ECU? And this is where another layer comes in called as zonal computers. Now, zonal computer is slightly powerful than ECUs. So you shift the certain parts of your load between ECUs, fleets of ECU and the zonal computers, and then do your actions, where the latency is slightly higher because you have to circulate the data in the either it's a CAN bus communication or in the new eBari architecture, it is Ethernet, automotive Ethernet. The next layer is telematics unit. So once the data gets collected from these sensors to ECUs to zonal computer, before sending to telematics unit, you have what is called as vehicle computer. So now the connectivity part is beyond a vehicle, which means every data generated by 200 plus sensors, 100 plus ECUs will get accumulated in what is called as vehicle computers. And this is where 80% of the AI loads are run. And this is how you now look at what is the compute available for me to drive AI loads, which is in a car, and then distribute to vehicle computer, zonal computer, ECUs, and then drive your use cases. When I say use cases, it could be a simple infotainment system. It could be a simple personalization recommendation engine, or it could even be a mission critical vehicle steering or a braking system. Now you need to understand what kind of a use case needs what kind of a latency, and then drive your architecture in the system to enable and achieve that latency so that you cannot compromise on any of the facts. So as I said, latency, network bandwidth, data privacy, and cloud cost. In nutshell, if I summarize, every industry needs a different flavor of edge. And this should be understood by the ecosystem players. When I talk about Bosch, we are heavily into automotive industries. Now, you cannot have an autonomous driving car without certain ecosystem players contributing. On one side, we say we develop applications. Qualcomm, QuickTel says we develop 5G chipsets. On the other side, we talk to MNUS who says, okay, I'll give you SIM cards which will give you 5G connectivity. But each one of them, if they don't talk to each other, I don't think in India, at least in European countries where we have our presence, there is certain consortium which is already formed where the responsibilities are equally shared. And there is a big question in India that if I generate a data, for example, Mahindra's Tatas, if I generate a data, who will own the data?
Quite, yeah.
Is the vehicle manufacturers,
Correct, yeah.
is the application owners, or is it the MNO?
Interesting, yes.
So this is where we drive edge compute in different flavors in the industry, and the expectation is, I think different players of the industry have to come together to make sure that edge goes to people and then impact.
Thank you. Thank you, Dr. Prasad. Now, Pradeep, in VMware, you're known for adoption of new technology. You are usually the first ones around it. Now, in India, especially, the 5G adoption is very rapid. I mean, we already have close to 10 million subscribers in 5G. Now, how does this rapid adoption, influence the data center landscape in India?
Yeah, great question. And, taking off what Guru was talking about, I think the relationship at a business level between 5G and edge, it's almost, I would call it symbiotic. I mean, one feeds on the other. You mentioned rapid 5G adoption in India. You could argue about that. I mean, you travel across the breadth of Delhi, for instance, and you'd watch your phone, you'd see 5G, you'll see 4G, you'll see 5G again. And so, and that by definition is how networks are rolling out in this part of the world, right? It's the deployment of 5G infrastructure is staggered. Not all use cases, the ones that he talked about, are possible on day one. But it's a chicken and egg thing, right? If all of these, because as telcos build out these networks, you start with islands of 5G, in pockets of 5G where it's available, and you expand. But as you roll this out, you also want use cases that make it viable for telcos to roll out these. And so it's a chicken and egg thing. So if you don't have the infrastructure, the ISVs, the providers of these solutions will not build out these use cases. And if you don't have the use cases, the network itself is not monetizable. So, you need both. And so so edge data centers, I would argue, operate as a bridge. They will give you the ability to deliver near 5G use cases even without, massive 5G rollouts. And so, as you talk about, he talked about what 5G means. You need huge network bandwidth, and you need very low latency. You're talking about, in the 4G world, what are we talking about? 60, 70 millisecond latency? 5G is supposed to deliver 1 millisecond latency. I mean, that's a huge difference in customer experience that we're talking about. Absolutely. And even now, as we have 5G in market, as everyday users, you haven't seen use cases that take advantage of this capability. And so I think there's the argument to be made is that, hey, 5G, while this compression and latency is possible in the lab, in real terms, you'd possibly get it down to maybe, you can deliver reduction in latency maybe 10, 20 times, but you'll still need edge where you do not send all of this back to the core so that you can deliver that, near 5G kind of use cases to the mass as networks build out. And as you build out these networks, you would start to see use cases, generate massive amounts of data. Traditionally, we've been used to, human consumption driving this amount of data. There's a cricket match going on, and I'm sure on Hotstar, there's probably at least 2 crore people watching at this time, right? And to deliver that kind of use cases, you need CDNs that are able to scale to that level. And it's kind of difficult to do that unless you're close to where the content is generated. So unless you cache it to where people are consuming. And so, and you mentioned IoT, Guru talked about it, right? That's the other big use case that will just explode. So to take advantage of or to serve this, this explosion in data that will be generated as 5G takes off, at a point, it will overwhelm even the capabilities of 5G. And so you will continue to need the ability to determine what is the data that you send all the way back to the core, and what would you process close to where it's generated. And so 5G and edge are symbiotic. One feeds on the other, one helps. So initially 4G edge data centers will bridge, and eventually edge data centers will enable 5G to really deliver on its promise at scale. So I think that's what we're seeing, and you can see the results already, right? You're starting to see edge data centers come across the country, right? So states are competing. Karnataka has announced a whole bunch of new edge data centers. UP has announced another 100 of them in that state, and whether you are in the private sector, people like NextGen, or whether you're in the public sector, people like RailTel, they're all building out edge data centers. So I think what you'll see, with 5G is the spark that leads to an explosion of low-cost, low-power consuming edge data centers that will dot the landscape of this country.
Absolutely. Thank you so much. I mean, quite an interesting viewpoint, especially when it comes to infrastructure development. This is probably a question to the wider panel over here. And I would like to start with the operators first, obviously, because that's where the infrastructure probably rests right now. And so what kind of, infrastructure and technology advancement do you think are necessary to make this 5G and edge computing a reality for data center? I mean, you would require a different kind of architecture altogether, I'm assuming, right? So, Dr. BP Singh.
That's right. So I'll explain this in very simple way. So it's like layers of different technologies. All right. The first layer is edge data center infrastructure. All right, and that's where there are a number of things which are happening. The first is the micro data center, which is how do you build data centers in a smaller footprint very, very quickly. We call it modular data center, which are like in the form of containers. So you ship a container, put all the capabilities and you're on. Second is the location. Strategically, depending on the application use cases, you decide saying where your physical edge data center has to stay. Third is power and cooling. So the technologies which manages these remote sites have to be of different grades so that it can sustain on its own. And in the physical space, the first layer, which is the physically we are looking at, last but not the least is the physical and the logical security as to how do you protect this facility which you have kind of planted in some remote place, and how do you make sure the data which gets generated or stays there locally is actually being protected. So there are a number of other things which happens at the higher layer. So that's the first layer, which is the grounds up. The second layer is the network infrastructure. So requirement number one is it has to be high speed, so that whatever is happening there can be emitted very quickly wherever it has to travel to. Then there are technologies like SDN, where you could, it's called software defined networks, where you could programmatically define which network has to go where, and there is no physical cabling and things like that. So that helps in terms of doing that. In case of 5G, there is something called MEP, which allows you to move compute on the network side.
Correct. Yeah.
Closer to the network, so that network optimization, many of the 5G features, they get enabled. So this is first layer. The second layer is where edge compute technologies comes into play. So there, the first thing is how do you manage this whole thing? Because in remote facilities, you would not have too many people to take care of it. So the full orchestration of edge resources, monitoring, managing of them, taking actions if something goes wrong, that has to be done at that layer. Next layer is the processing layer. Sorry, the containerization and the virtualization, where VMwares of the world, Red Hat and Nutanix, some of these partners, they come into play. They got all those capabilities which can be leveraged there in terms of having K8s, K3s, and the virtual machine getting spawned up. Next is real-time data processing, so that as and when this data is getting transmitted, so you got all the capabilities in terms of messaging bus and the capabilities in Kafka and many of those technologies, which allows you to do local processing at speed. And at that layer, the last is the AI and ML capability on the edge, which our co-panelist also mentioned. Because
Correct,
one thing is very fundamental, and that's why he said that as has got different definitions. All right. So it depends as to what is the value of this data. Right. What is the time after which this data loses its meaning. So some data is like critical, saying within few milliseconds you go to do whatever you want to do. Otherwise, beyond that, there's no relevance of that data.
Correct,
right?
yeah.
There could be some data where probably it has value maybe for 300 seconds. All right. So, I mean, those kind of processing probably can move to central data centers and not necessarily on edge, which he spoke about. So it's about the relevance of data, and that defines as to what does edge means for that particular data.
Absolutely.
Next layer comes security and compliance, because that's actually a major factor. I mean, these locations, data is being contained. How do you maintain sovereignty and locality of data of the data, given the government policies? But the most important thing, which is very relevant, is the next layer, which is the orchestration and the management layer. right? Because for a given enterprise, there is not going to be a situation saying everything you want to do on edge. It is always going to be a combination of edge, your on-prem data centers, and the public cloud facilities, so that you actually manage different data getting processed at different layer depending on that relevance of that data. I mentioned millisecond, minute, or seconds, and that's where this layer which orchestrate manages this is important. From the service provider perspective, it becomes even more complex, because if you are serving different customers on the edge, so then rules of multi-tenancy, how do you produce bills to them, how do you build capabilities in terms of customer A may want X number of capabilities in terms of products which they may want, customer B may want something else. So that's where this whole complexity involves.
Mr. Khurana, your views on this? As a service provider, I mean, it's essential. Yeah.
Whole 9 yards. So I'll,
Absolutely.
not for the sake of repetition, I'll pick up the most important aspects that I think are important from our perspective. I'll start with a logical approach, saying, why did we start building edge first of all? It was requirement of latency and throughput, everybody knows that. So the equipment infra changes required are to support low latency and high throughput. They should be capable of doing business analytics and service analyzation, so that whatever is the customer requirement for which we put the edge there should be done. I should not be taking all my throughput back to my core location and say, okay, I'll handle it there, because that's a very expensive piece to do. So let's not forget why we started this discussion. So one is the infra should support my latency and throughput applications. Next one is the second reason why we put edge was data sovereignty. You touched upon that. There are multiple industries who do not want to expose the data to a remote location.
Right.
So they would like to have it captive or at the edge location. So the infra should be able to maintain that data sovereignty and give a virtual network piece to each enterprise, saying this is secure area for you. So that's very important. Third one, you talked about single pane of glass for management. You touched upon a hybrid piece where the data is co-hosted between an edge location and a central location. I would rather say it is multi-tenant as well, because it is a land of now startups coming up, and each one of them would not be able to put up their own piece of private network and edge network. So we should be very careful. If we give edge for a multi-tenancy solution, you should be able to manage in such a way that everybody has a secure piece available to them.
Correct.
So these are three pieces which are very, very important for me to manage. One is infra, to give service to the consumer, analytics to the consumer, service consumption to the consumer. Number two is maintaining their sovereignty. Number three is management in such a way that not only a hybrid structure of hosting workloads on different locations, different clouds, but also multiple tenants in the same cloud should be able to be managed through this infra change. So you touched upon all. I've taken three of the most important pieces which are important to me.
Yeah. So I want Pradeep and Poiter also to kind of weigh in on this. Both of your organizations need to probably catch up or already are at the forefront of this new architecture which is coming up in data center, right? So, and VMware and AMD have a very big role to play on this one. What are your thoughts around this?
So let me start with a processor. Everything starts with a processor, effectively, So I'll take a credit for the industry, because we don't make it happen, but we definitely enable. So let's think for a moment about mobile phones. The processing capabilities of these devices a few decades ago would be only done by a few racks of servers, which would consume tens, if not hundreds of kilowatts, and would cost hundreds of thousands of dollars. If we did not make such a spectacular progress, the devices that we use right now would not be a reality. And, it goes for all of the, technology effectively. But what it is with the semiconductors, there are two things that, the advancement goes in. First is innovation in microarchitecture. So making a processor much more efficient and much more performant within a power envelope, And effectively what we've been looking for is provide maximum performance in affordable power and affordable cost. So one is the microarchitecture improvement. The other one is using the latest semiconductor technology. So in other words, how small is the transistor that it's building the microprocessor. And just to give you an idea, when 60,000 and x86 processor started, it was about probably 2 to 3 micrometers. Okay, that was the technology. So it's 2,000 to 3,000, depending on a point in history, nanometers. When I started my career, the devices were manufactured in 0.65 micron, which is 650 nanometers. Today, AMD is shipping devices with 5 nanometers technology. Yeah. And what it means is basically we are bringing exactly that, this performance efficiency into data centers and into the edge data centers as well. In edge data centers, infrastructure, there are like 4 main factors that you really need to drive to. Maximum performance within a low power envelope, and for a server, of course, there is a certain power budget. For processors, typically is about 200 watts. Then, of course, there is a space limitation in most of the edge locations. So, servers needs to be a shallow depth and, be able to dissipate all of the power. And then the fourth thing is, the cost, which is much more challenging. So we are developing specifically the devices to do exactly these functions. So AMD has released a product only a month ago, EPIC 8004, which is exactly putting an extraordinary number of cores. Right up till now, the industry was able to do about 32 roughly processor cores in 200 watts. Right. We are doing 64 cores in 200 watts. In data centers, what we are fighting for is the compute density. What Gulshan mentioned about the power rack, power limitation, which is 30 kilowatts. So the key thing is really to load as many processor cores as you can into that. And through that, you will be achieving much better power efficiency, which translates into saving cost, but also it will translate into sustainability.
Right.
So these are the key factors for us.
Pradeep, your thoughts, please.
Yeah, thanks. So a couple of things, right? So once, as you get closer to the edge, you want the ability to run the same applications that you're running in your data center at the edge. And so that's the first key thing that we do as VMware. We help deliver an edge compute stack, which is stripped down, bare bones, at low power, which is able to, allows you to deploy the same applications that you traditionally run closer to the data center. So you don't have to refactor, rebuild, rewrite your applications. At the same time, if you're building what we call edge native applications, you have a stack that's optimized, that is available to be deployed at the edge, that you can take advantage of. So that's the first thing that we do. The second thing that you look for as you look at these changed architectures that BPN talked about is the ability, as we get close to the edge, traditional applications or traditional architectures usually have to deal with what we call IT applications. As you get to the edge, you also have to deal with what we call OT applications, like what Bosch talked about, right? And so to be able to have an orchestration layer that manages or has the ability to orchestrate devices across all of these platforms, your traditional IT applications, your OT applications. The architectures are usually different. Traditional IT architectures usually have a push architecture where you push out updates. OT applications usually have pull orchestrated architectures where you seek updates that are required. So these are different, and so can you build an orchestration layer? And Geo seems to have done some of that themselves. But we would argue that, can you build out an orchestration layer that enables you to manage infrastructure, networking, and security across these disparate platforms with one single console? And that's, again, something that a lot of our clients are asking for. And that's, again, something uniquely that VMware offers. So as you build out these architectures at the edge, you have the ability to, one console that rules them all. So these are the two things that we look for, an edge orchestrator and an edge compute stack, and both of these we I think can deliver unique value as telcos and service providers look to roll out these applications.
Thank you. Virul, what are your thoughts on infrastructure development which is required? You know, I mean, considering the third most visited website in the world right now generates 5 petabytes of data in a day, so that's huge. So, I mean, you and Dr. Prasad, both of you, if you can give your viewpoints on that, yeah.
So yeah, in the infrastructure side, obviously, in terms of 5G services, I mentioned previously that these are microservices based, and your data plane is now closer to the edge of the network. That means you need to run in 5G user plane function, and there with the Open RAN elements such as central unit, distributed unit, and remote unit, especially distributed unit, they will be closer to the edge of the user. So you want to have basically enable these data plane functions faster and faster.
Right.
And that is the key to enable higher data rates. So that means if you want to make your data plane faster, you also need to make sure that your system uses enhanced platform features as much as possible. Piotr mentioned silicon advancements. So basically, silicon is always making sure that their architectures are aligned to expedite processing of tasks so that you can bring that real-time performance. But this also has a full stack implication. So from the application all the way to the user, you need to basically streamline this delivery of the data when the amount of data and the types of data also differ, because on those systems you will run IoT systems that deliver data at certain frequencies, at certain time periods. At the same time, you will also have some application that stream the data in high rate. So they live together. So you would need to have a platform that can enable microservices-based deployment of these, at the same time consume the platform's enhanced features. So for that, basically, in Canonical, we work with all the silicon vendors to bring real-time capabilities to our operating system kernel. That enables fast execution from silicon all the way to the applications. And at the same time, there's the necessity to have virtualization platforms that make use of these advanced capabilities. So you have lots of new data features such as DPDK, SRAV, huge pages. All of these capabilities are needed at the microservices level. So your infrastructure, virtualization infrastructure, must also support these features so that you can deliver the data from all the way from silicon to operating system and now to the virtualization infrastructure, which will host the pods or virtual machines, whichever you are using, so that those applications can consume, can receive this data in an agile way, in a timely way. So that's really important, because if you bring the data center to the edge, but do not employ an infrastructure that can enable fast response, then you only do the half of the job. So you also have infrastructure, hardware, everything, full cloud, optimized in that sense.
Yeah, the synergy is extremely important, right?
Yeah.
Dr. Prasad, your viewpoint, please.
Maybe I'll reiterate the question. It's more on what infrastructure do we need for edge compute to succeed. Maybe in the context of Bosch, technologically we are already into the space of edge and 5G. We are developing capability, we are developing assets which could be building blocks from a technology standpoint. But what is missing in the ecosystem is what it would be worth enough to discuss. If you come from top, of course we have cloud centers, which again, let me reiterate, edge will never be able to replace cloud. So edge and cloud have to work together. From a top down, if I come, cloud centers are must. It has to have decentralization, which means you cannot have a cloud center in Europe orchestrating data coming from India. So it means decentralization of cloud has to happen. Of course, we have Amazon, we have Azure's, they'll take care of it. The next layer is you have cellular towers today who are enabling 5G technology. Today, they are actually just transferring data. In the context of edge, they should also now enable necessary infrastructure to compute data going through them to the cloud, which means a heterogeneous compute environment where multiple parties in the ecosystem who are competitors will also be able to confidentially, trustably use that infrastructure. Second is cellular towers. third, which is in the context of mobility, the expectation here for autonomous driving is every traffic signal in the world should be connected to each other, which means, imagine I have 10 traffic signals in a geography. Are they connected to each other? Are they talking to each other? So this is the third layer. Fourth layer is, can the moving parts in the vehicle, for example, when you talk about vehicles on the road, there are more than 20 different companies who are taking their vehicles onto the road. It could be Mahindra, Tata, Kia, MG, BMW, Audi. Now, all of them have to trust this nearest edge center, which is traffic signals. So, which means the data coming out of vehicle has to be published trustably to these traffic signals so that traffic signal load can be again distributed and certain infrastructure enablement can be done. The last layer is, as a vehicle, am I smart? Which means the data generated, can it be used? For example, to ensure that I either steer my steering or manage my braking, I doesn't have to take the data to traffic signal. Can I use the data in the vehicle itself? So first layer is, can the data developed in the vehicle be used? Second, if yes, if it's required to be doing more, to go to the next level, which is traffic signal. If yes, if you have multiple traffic signal, I have to manage a traffic signal of a large geography, then go beyond traffic signals to a cellular tower. And if cellular tower also needs to be bypassed, go to cloud. So at different layers, players have to come together to build this infrastructure so that a cohesive environment can be brought in to drive certain use cases to impact the society.
Yeah. That's quite an interesting example. I mean, today we have touched everything from sustainability, scalability to how to solve traffic jams also. I mean, that's phenomenal. So with that, we have some time to take some questions from the audience. If there's anyone who wishes to ask any questions this elite panel. Yes, please. Please do state your name.
Yeah, I am Brigadier Sanjay Rawal. I am a veteran from Indian Army. So the question to Dr. Guru Prasad, you said the data center will be there and we require the edge also. My question is, data center, the investment and other things which we have got and other things is based on a lot of power supply system, real estate and all that things coming up. It's a big investment coming up. And now we are having similar things, want at isolated locations. He covered something about the strategy part of it and the security point of view. So my concern at a bigger thing is, so much of power will be required at various places. So are we going on to that, now we open up a new field by itself. That is one thing. From a data, to sustain all this, the energy will be required. So we're talking about green technology and everything. But a lot of investment in terms of data centers coming up, and now we are trying to go at the edge level.
Okay, so I think this is a very prominent question. People talk about sustainability and carbon footprint of edge compute.
Yes.
I think it is debatable. Today, I don't think any of us have answers because we have not done it. We are only visualizing what could happen in next 5 years. But if the architecture with which we are now driving, which means every traffic signal should have compute power, every cellular network should have compute power, it's humongous. If you look at India, just India, the power consumption in each of these infrastructure cannot be even imagined. So I think slowly we will get used to very simple demonstrators. For example, in Germany, we have demonstrated what is called as AVP, automated valet parking, where a vehicle, you have a simple app in your phone, you just touch it, where the vehicle automatically navigates to a nearest and safest parking lot. So which means vehicle have to talk to an infra has to talk to a status of the parking, which is quite far, and the vehicle should navigate. So you have infra in each of these nodes which talks to each other. But at a scale, Mr. Singh was talking, we have really not demonstrated it. So it's still an open question if you ask me.
There is a lot to foresee when it comes to 5G and its ability. Yes, please. The mic is right there, yes.
Hi, Kamath from Ericsson. I wanted to check on, we have, a cross spectrum of, operators, vendors, and PaaS and CaaS, IaaS providers. So do you see in the edge, IPUs and DPUs being deployed more and more? You have offerings from AMD, Intel, NVIDIA. VMware has worked on integrating their stack onto some, but I'd like to know whether they're relevant for edge data centers in the use case you've talked about, whether IPU, DPU adoption is increasing.
So who would like to take a first stab at it? I think the operators would. Can you just kind of...
So, oh, sorry. I was asking a specific question on IPUs like the Pensando chips, as well as NVIDIA Bluefield, or Intel has, your own offerings that are coming into the computes. So I wanted to understand whether from an edge standpoint, these sort of compute configurations are being leveraged or going to be leveraged anytime soon.
So yeah, I think, yeah.
So definitely, yeah, definitely. What at AMD you were asking about Pensando? Actually, this is an AMD group right now. We've got a data center business unit, and this data center unit, actually business unit, combines all of the silicon technologies effectively. CPUs with EPIC microprocessors, and then with GPUs, and then also DPUs, data processing units, and that's exactly the acquisition of Pensando. And we are working with the vendors, working with customers, really to create the total solutions. So Pensando is being deployed right now in data centers, and and you are getting a lot of benefits through that. Each of the functions obviously is contributing. With DPUs, we've got exactly the optimization of data path and passing in between the data centers and racks as such. So yes, this optimization is happening, and there is a holistic view that we take there.
Thank you. Thank you. And with that, we come to a close for this discussion. Thank you so much to the panel, and thank you to the audience for some questions. Thank you. Yeah, just give us a moment. We'll just give some moment. Yeah. Thank you so much. Well, thank you. Dr. Prasad, thank you so much. Pradeep, thank you for attending. Thank you.